Hi all. Now we can discuss the concept of reciprocal lattice. Okay, so till now we have discussed about real lattice. So real lattice basically represent the possible positions of atom or molecules in a crystal lattice. Okay, so in other words, this real lattice we represent the spatial distribution of position of atoms. So it gives spatial distribution of position of atoms or molecule. Okay. Now, according to the free electron theory, the wave function of the electron, in general, we can write the psi of r is some a times e raised to I k dot r. Then the corresponding momentum, so the momentum operator acts on psi of r would give minus ih cross del acting on a times e raised to I k dot r. And obviously this would give h cross k times psi of r. So this h cross k is nothing but the momentum, and k is called the wave vector. Now, what are the possible values for the wave vector in case of the free electron theory? Now, remember this psi of r, the wave function of this free electron, has to satisfy the periodicity of the lattice. So, if capital R is a lattice vector, so what is in the lattice vector? So, if a1, a2, a3 are the primitive lattice vectors, then in general, m times a1 plus n times a2 plus l times a3 would give a general lattice vector. So here a1, a2, a3 are called the primitive lattice vector. Okay, now this wave function has to satisfy the periodicity in such a way that the psi of r plus r must be equal to psi of r. So this condition makes a restriction on the possible values of k, because what is psi of r plus r? It is nothing but e raised to I k dot r plus r. That would be equal to, there is an a here, so a e times of I k dot r. So e raised to I k dot r is common on both sides, so that will cancel each other. So and a is also cancel. So this implies e raised to I k dot r must be equal to 1. Or in other words, this k dot r must be some multiples of 2 pi. So the value of k is restricted. So these values, the values of k are restricted, and it has to satisfy this relation. So k dot r must be equal to m times 2 pi. Okay. Now this k, again we can write as some hb1 plus kb2 plus lb3. Okay, so b1, b2, b3 are the primitive vectors for k. Then k dot r can be written as hb1 plus kb2 plus lb3 dot ma1 plus na2. Okay, instead of L, okay, better we can put some SA3. Okay, now this must be equal to some multiples of 2 pi. Now it can be easily achieved if you include this condition, that is AI dot bj equal to 2 pi times delta ij. That is b1 dot a1 would be 2 pi, b2 dot a2 would be 2 pi, b3 dot a3 would be 2 pi. All other terms are 0. So if that is the case, then this k, which is equal to hb1 plus kb2 plus lb3, can be called a reciprocal lattice vector, and this b1, b2, b3 are called the primitive reciprocal lattice vector. Now the lattice formed by k is called reciprocal lattice. So why it is called the reciprocal by this term? Because if you look at k, the k dot r is some integer. Okay, so it is some multiples of 2 pi. So it is a dimensionless quantity. So k dot r is dimensionless quantity. Now what is the dimension of r? Dimension of r is length, because r is the lattice vector. So dimension of r is length. So therefore, if you look at the dimension of k, which would be equal to reciprocal to length. So 1 upon length. So that is why this the k vector is called the reciprocal lattice vector. Its dimension is inverse to the length. Okay, and moreover, it is connected to momentum. So therefore, this reciprocal lattice vector, we can say that it is the possible momentum representation. Okay, so reciprocal lattice vector or the reciprocal lattice can be interpreted as representation or representation of possible momentum. So basically it represents momentum space. Okay, so the real lattice, the direct lattice, which represent the position, the possible position, and the reciprocal lattice represent the possible momentum, because the h cross k gives momentum, and k is discrete. The k cannot take any values, so k is discrete. So k can take the values only hb1 plus kb2 plus lb3, like the vector r. The vector r is ma1 plus na2 plus sa3, where m and s are integers. So here the hkl are integers. Okay, and there is one more thing. So if you write vector k, which is called the reciprocal lattice vector, as hb1 plus kb2 plus lb3, then this k would be perpendicular to plane hkl. So finally we have to add the few more points. So if in case of a three-dimensional lattice, if a1, a2, a3 represent the real lattice is in the direct lattice, then the b1, b2, b3 can be easily defined like this. So b1 would be equal to 2 pi times A2 cross A3 divided by A1 dot A2 cross A3. So this is B1. So similarly, we can write B2, B3. Only thing is you have to cyclically change the numerator. There is no need to change the other quantities. So this is defined in this way because your A1 dot B1 must be equal to 2 pi. So the certain textbook define the lattice like this. This A1 dot B1 would be equal to 1. So in this way also the reciprocal lattice can be defined because in some textbook what they will do is this 2 pi is already taken out. So there is the psi of r, it would be written as I times 2 pi times k dot r. So 2 pi is already taken outside. So therefore this k dot r, sorry, if you look at here, the 2 pi would be already come here. 2 pi would also be come here. So 2 pi will come here. So that means the k dot r are simply equal to an integer. So this is the convention followed by certain textbooks. So therefore, in such cases, the definition of the reciprocal lattice or the connection between the real lattice and the reciprocal lattice would be ai dot bj equal to delta ij. Okay, so this also we have to keep in mind because sometimes yeah, the question may be based on this kind of convention, and sometimes this would be based on this type of convention. Okay, so depending upon the choice, you can choose the right way of answering the question. Okay, there is no much problem because all the your questions are not descriptive. The questions are multiple choices, so the choices would be there already, so you can easily get it. So only difference is some convention. There will not be any 2 pi on the right side. Okay, so for three dimension, we can directly find the possible reciprocal lattices by using this kind of expression. But for two dimension or one dimension, there is no particular formula. Okay, so we have to explicitly find out the possible reciprocal lattices. So while the discussing questions, discussing problems, we'll discuss one problem related to two-dimensional case. Okay, and the last one, so in three dimension, for cubic lattice, we have three different lattices. One is simple cubic, face-centered cubic, and body-centered cubic. So this is a real lattice. So the three dimension reciprocal lattice for simple cubic, we'll get the reciprocal lattice is in the shape of simple cubic. But for face-centered cubic, the reciprocal lattice would be in the shape of body-centered cubic, and for body-centered cubic, the reciprocal lattice in the shape of face-centered cubic. Okay, so how to find that? So the simple cubic is like this. Okay, so we'll choose one lattice point as origin. Then just draw the vectors to three nearest neighbors. So one of these vector can be represented as A1, other one A2, the third one A3. Okay, so A1, A2, A3 is defined. Now from which we can calculate B1, B2, B3, and B1, B2, B3 will take the same structure. And when you're going to uh, symbol cubic or face-centered cubic, okay, we can go for face-centered cubic. So in case of face-centered cubic, okay, so in case of face-centered cubic, if you choose this point as your origin, then the three nearest neighbors, okay, this can be one nearest neighbor, the second nearest neighbor, third nearest neighbors. So three nearest neighbors. So so this can be represented as your A1, A2, A3. Okay, so it will have some representation. So from which we can calculate what is your B1, B2, B3, and B1, B2, B3 takes the body-centered cubic system. So finally, when you draw the body-centered cubic system, in case of body-centered cubic system, usually we take the center point as your origin. So we can draw three nearest neighbors. It's your choice. Okay, so A1, A2, A3 can be defined. Okay, now in simple cubic, what is the structure of A1? So A1 can be similar as A times I, A2 can be A times J, A3 can be A times K. And in case of a face-centered cubic, A1 can be, okay, so we have to put your IJK. This can be I direction, this can be J direction, this can be K direction. So A1 is A by 2 I plus K. A2 is A by 2 I plus J, and A3 is A by 2 J plus K. Now for face-centered, body-centered cubic, the A1, okay, so again we have to put directions first. This can be K direction, this is I direction, and right side is J direction. So this is A by 2 is plus I plus J minus K. So A2 can be A by 2 I plus J plus K, A3 A by 2 minus I plus J plus K. So then better you choose not this A2. So we can choose this is my A2, then it will have the same structure. So if that is your A2, then instead of your plus, so we can put a minus. So this is the body centered real lattice, face centered real lattice, and simple cubic lattice. Now from which we can calculate their reciprocal lattices by using this definition B1, then B2, then B3. Then for simple cubic, the B1, B2, B3 takes the same structure. So that is why for simple cubic real lattice, we get the reciprocal lattice also simple cubic. But for face-centered cubic, this is a structure of real lattice. And if you found B1, B2, B3, the B1, B2, B3 takes this particular form. This would be in this kind of structure. So that is why for face-centered real lattice, we are getting the reciprocal lattice of body-centered. And finally, for body-centered, the real lattice, the reciprocal lattice B1, B2, B3 takes this kind of structure. That is why for BCC we are getting FCC reciprocal lattice. Okay, so that's all for the discussion about the reciprocal lattice. So next we'll discuss the problems related to reciprocal lattice in next videos. So thanks for watching this video. See you soon. Bye.